Hey, welcome to Advent of Code day number 8, and we are again trying to solve Kotlin code puzzles, and today there will be 2 again, and yeah, let's just start, I guess. And if you're wondering if the intros will get even more cheesy over time, yes, I will try very hard. Day 8, 7-segment search. You barely reach the safety of the cave when the whales smash into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth. So you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of 7 segments named A through G. A, B. Oh, okay, those are actually numbers. It looked like garbage to me at first. Okay, this is a 0, 1, 2, 3, 4. A, B, C, D, E, F, and G. Okay. So to render 1, only segments C and F would be turned on. Yeah, those 2. The rest would be off. To render a 7, only segments A, C, and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on a signal wires A through G, but those wires are connected to segments randomly. Okay. Worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. Okay, so you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1. C and F, yeah. So it must mean segments C and F are meant to be on. With just that information, you still can't tell which wires B and G goes to which segments C and F. For that, you'll need to collect more information. Okay, for each display you watch the changing signals for a while, make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. Okay, for example, here's what you might see in a single entry in your notes. So are those 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, digits 0 to 9 in a random order. And then a 4-digit output value, so this is the output. The entry is wrapped here to 2 lines, so it fits in your notes. It will all be on a single line. Each entry consists of 10 unique signal patterns, a pipe delimiter, and finally the 4-digit output value. Within an entry, the same wire segment connections are used. Okay, here. So A is mapped to the same thing for all A's, okay, I guess. The unique signal patterns correspond to 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, D, A, and B, in the above example means that to render 7, the signal lines D, A, and B are on. Because 4 is the only digit that uses 4 segments, E, A, F, B means that to render 4 signal lines E, A, and F, and B are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value C, D, F, and so on use 5 segments and are more difficult to deduce. Where's the example again? Oh, here. Yeah. Okay. For now, focus only on easy digits. Consider this larger example. Because the digits 1, 4, 7, and 8 each use unique number segments, you should be able to tell which combination of signals correspond to those digits. Counting only digits in the output values, the part after on each line. In the above example, there are 26 instances of digits that use a unique number of segments. Okay. In the output values, how many times do digits 1, 4, 7, and 8 appear? And then we need a puzzle input. Alright, that's a lot. So let's see, how can we solve this? Let's move to IntelliJ. And then, as always, we try to get our input. Drop it in here. And we rename it to day 8. No, was wrong. Day 8. Now let's create a package for day 8. And some functions. And we execute part 1 first. So we need to break down this problem first. So we only care about the simple digits, which are all unique, have a unique number of segments. So they should be super easy to identify, I guess, because we only need to look for strings at a specific length. But I feel like this is already hinting at part 2, where I assume we will need to identify all digits. So identifying the easy digits first might be the first step into this direction. So I almost guess part 1 is trying to help us here. Other than the problem with the lanternfishes, where the example tried us to implement or hinted at implementing a solution that was not performance-wise a good choice. But here it seems like a good thing to do this. But we should not only try to find those strings at this length, we should also try to maybe already start identifying those numbers and make sure we can use this in part 2 if we need to find all digits. So I guess the thing we want to know is if we find the 1, then we can pass in the characters already, or remember the characters already. We can say 1 is C and F in this example where it's correct. And if we identify the 4 was the other one, I guess we could say B, C, D, and F and keep those lists, because they might help us later identifying the actual mapping. Yeah, let's try this. So we get this kind of input, right? Now I'm wondering, like, we could start to find, this is the 4, The one. Oh. Yeah, there's one interesting caveat here. Like, we see those signals. The one, we know the one only has 2 segments. So this needs to be 1, G and F. But later, we actually get F and G. So we need to also be aware of the order later when we want to identify the actual digits. So how do we do this? Like, if we only try to solve the problem of part 1, it's super easy to just look at the strings and find the ones with specific length. But that is maybe not what we want to do. Maybe we want to read this, identify the 1, 4, 7, and 8, and then look up how many of those do we find in here. Let's try this. And let's use this as an example here. Oops. Oh, yeah. I'm just hoping Codepilot does not autocomplete those comments, because then we are pretty much fucked. Okay. So how do we represent this once we read this? It's a list of strings, but since they are ordered, it's also kind of a list of characters. So maybe it's a list of lists of characters. And if this is our input, what do we actually want from a function here? We could 1, 4, 7, and 8. Let's take a note of this too. 1, 4, 7, and 8. We could call it, we could create functions to find 1, 4, 7, and 8. For example, we could do find 1 and sorry, that's the GitHub Codepilot. We don't need this, and we could go away. We could just find the string with 2 characters. Find input, find, and then we try to find the one where the size is 2. Let's actually take note of this too. Like, we have digits 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0 has 6 segments. A 1 has 2. A 2 has 1, 2, 3, 4, 5. A 3 has 1, 2, 3, 4, 5. A 4 has 1, 2, 3, 4. 1, 2, 3, 4, 5, 4, 5. 1, 2, 3, 4, 5, 6, 4, 6. 1, 2, 3, 4, 7. Yes. 1, 2, 3, 4, 5, 6, 7, 4, and 8. And 1, 2, 3, 4, 5, 6, 4, and 9. And maybe we also take note of which ones already here. Oh shit, go away. 0, ABC, ABC, EFG. 2 has, no, what? 1, sorry, C and F. 2 has A, C, D, E, G. A, C, D, E, G. A, C, D, E, G, yeah. A, C, D, F, G for 3. A, C, D, F, G. 4 has B, C, D, F. B, C, D, F. 5, 5 has A, B, D, F, G, A, B, D, F, G. 6 has A, B, D, A, B, D, E, F, G, A, B, D, E, F, G. 7, A, C, F, C, F. 8, A, B, C, D, E, F, G, all of them, A, B, C, D, E, F, G. Okay, this means 7 segments, A, B, C, D, A, B, C, D, F, G. Same without D, yeah. Okay, now back. If we are trying to find the characters that are 1, find 1 chars. We need to find the one that has a size of 2. And if it doesn't, we return, we throw, I guess, throw, and we call it one not found. Maybe it's an illegal state exception. And the idea is, if we make this more complicated now for this first part, we can reuse this later to find the ones, the 1, 4, 7, and 8, and then try to use those to find the other ones. Maybe. The 4 has 4 segments, the only one with 4 segments. So it's kind of the same with 4. 4 not found. Then for 7, find 7 chars. Oh, sorry. For those 7 chars, it's 7 has 3. 7 not found. And then we create one for number 8. Let's see, maybe we can simplify this later on, which has exactly 7 characters. So if we now pass in this to a list, and we try to find the mappings, I guess, find mappings, and our input is this stuff again, and we want a map from digit to its list of characters. And then this will be return. Yes, that is almost what I want to write, but the mapping is wrong. 4, 7, 8. Is this what we want? Or do I need actually the opposite? Maybe we do the opposite. 2, 1, 2, 2, 2, no, 1, 4, 7, and 8. And to make it nicer, we will also sort them, because as we saw before, they might actually be in a random order, not sorted. And then we kind of need something that turns this into our numbers. Let's call this translate. We get an input, which is, go away, list of, no, go away, list of characters, list of characters. And what we want out of it is maybe a string, since it can start with a 0 actually. And then we try to get the mapping, find mapping, so go away. And then we take the input, and then we map it to, go away. So every value is one of those, and we need to sort it and look it up. Well, translation, mappings, and then we look up the value, but sorted. And now it is possible that it does not exist, since we do not have all the numbers yet. So how do we maybe return this as a list of characters too? Because then we can say we map it to its new value. And if it does not exist, we use a dot right now. And return this, and this means it is this, what? Yeah, we take the input, we map it. Every list we get either a character from here. Oh, this is a number. It's a number right now. Maybe return a character here too, since, yeah, we might lead with a 0 and then an int. It's not nice to concat. Now let's test this. And this will not give us the answer for part 1 yet. This is just doing a weird translation that is not helpful yet. I'm just hoping wait. Oh, this is, we also need a kind of a value. We do not want to translate the list, we want to translate the value. Or how is it called here? Each entry and then output value. Okay, this is the value. Then we should rename it here. This is a digit or segments actually, and we map the value and not the whole input. So this is our input. Why is this so weird? This is the value. Now we pass in the input and the value. Get the translation. Okay, what's wrong? Oh yeah, this is not. Split it by this, and then we map it to its list of chars, and then we do this here too. Still not. Int stream. Oh, chars doesn't returns what? An int stream. No. Char array. Okay. Okay, that's a bit weird, but I take it. Okay, now we have a translation, and let's just print the translation and get rid of this part. And you know what? Here we will create a checklist so that we know which numbers we can identify. If we do not need to identify all numbers in part 2, then maybe we did a lot of awkward work. Okay, we can find the 1, the 4, the 7, and the 8. And yeah, let's run this quickly and see if we can identify some numbers in here. We should identify the 4 and the 1, and 5 is... Yeah, we have a 4, a 1. Okay, let's join this. Four, 1, 1, which looks good. 4 dot 1 dot. I'm not sure why I said 4, 1, 1 actually. Okay, 4 and a 1. That looks awesome. So for part 1, what do we actually need? We need to read all the input and then counting only the digits in the output, so this part. And then we only for 1, 4, 7, and 8, right? You should be able to. Of digits that use a unit. Okay. So now we need to essentially. Well, we should maybe start by actually reading the input. Read input. What do we expect to get? We need a list. Yeah, essentially we need need the input and the value and a list of all of those things since there are multiple in the puzzle. Let's open this here. This is a list of characters. This is a list of characters, and we need a list of all of those. Okay, let's write this. So we want a list, and this list contains of no, we do. Sorry, we need a list of pairs of lists of characters, another list of characters, and we want a bunch of those. Okay, let's steal the code from yesterday for reading the file. We read day 8, we read all lines, and then we map them, and for every line we split it here. Line split, and can we deconstruct this? I cannot remember this. This is raw input and raw value. Both a string, yeah. And then we essentially do what we did above, which was here in our example, we split it. So we need a pair of the raw input split by, let's also trim it. Because if we split it here, we might have this space here we do not care about. So let's trim it, and then we split it and map it to a list of characters, and then we do the same for the raw value. And now I thought it would be what we want, but maybe. So we have a list. I said we wanted a list of pairs of list of characters, but we got a list of pairs of lists of characters, which is actually what we want. This is not a list of characters, it's a list of lists of characters. Maybe should have treated those as strings. All right. Hey, we can read input. So let's do the following. We read the input, or yeah, it's one item is called input. What is inputs? And now we can go away. Like sometimes Codepilot is really annoying if you don't want it to do anything. Now we loop over those and let's just print them for now, maybe. Yeah. Inputs for each. We get an input and a value, and then we translate it, and then let's just print every translated one just to see if everything is working nicely. Should get a bunch of, oh yeah, let's join those. Stop. We want to join them with an empty string. So yeah, now we have a ton of values, and the dots are all numbers we do not know yet. But it doesn't matter since we only need 1, 4, 7, and 8. Wait a second. Why do we have 9s in here? What did I do? 8. Oh, only the mapping is wrong. Feel sorry for all the people that are watching this and have been seeing this error for the whole time. Okay, nice. So we have 1, 4, 7, and 8s identified, and that's everything we need to count now. So instead of that, printing that, we map it, and then we sum by, that is deprecated, sum of Now we only need to count the 1s, 4s, and 7s. Count. How does count work? Returns the number of elements matching the given predicate. Yeah, that's what we want. It equals 1, or let's say it is in list of 1, 4, 7, and 8. Yeah, thank you, Copilot. That was actually helpful. And it is shadowed. Okay, yeah, sure. Character in this list. And then we print it, and if there's no mistake now, and this should be our sum. We only need to count them, right? Yeah. Okay, let's run this. 349. Awesome, that's the right answer. Now part 2. Let's see if we guessed right that we need to identify all numbers now. Through a little deduction, you should now be able to determine the remaining digits. Ooh, yeah, I hope so. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. So the unique signal patterns would correspond to the following digits. Yada yada yada. Then the 4 digits of the output value can be decoded. Oh, okay, because we now know this is 5 and so on, yeah. Therefore, the output value for this entry is 5353. Following the same process for each entry in the second larger example above, the following output value for each entry can be determined. Yada yada yada. Adding all of the output values in this larger example produces large number. For each entry, determine all of the wire segments connection and decode the 4-digit output value. What do you get if you add up all of the output values? Okay. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. Yeah, that is now the question. I can see how you can do it manually. I guess. By looking at the digits, what kind of segments do you know? But I'm not sure how we would do this. And how we would do this as an algorithm that works on any input. Well, let's try to figure it out. We have 4 numbers already, and the number, let's actually steal this here. Let's steal this. Let's only look at the 8. How do I... Can't remember how I use a multi-line cursor. Edit. It's somewhere in here. Find action. Multi-line. Well, we will do it manually. Or I will just draw it myself. A simplified version of this looks like this and is almost unrecognizable. Maybe we need to on each side. Make it a little bit more readable. Okay, so this is a simplified version. If we, let's also take this whole image in. We know, let's write down the segments quickly. A, B, C, D, E, F, G, and that's it. So we know C and F, we know 1, 4, 7, and 8. Yeah, if we know 7 and remove all the characters we know from 1, this will give us A. Because this is ACF, we remove 1, the characters in 1, then we get A. So A equals 7 minus 1. Let's also make a list of all the things we already know. We know A. What can we do with this? And can we, with A, can we identify an additional number? Yeah, if we add A to 4, no, we do not get 9, we also need G. But still, if we add A to 4, and then find the one that has one more. Huh. If we identify A, we can say nine is, oh no. Let's move this up too. Yeah, we could say 9 is the one with all the characters of 4 plus A and one unknown. But that is awkward to search for. Can we do this nicer? What about a 6? Or can we use those to identify other characters that we already know? We only know A. Let's actually try to implement this quickly. Can we find a 9 in here? If we can, then maybe we can start with that. Find 9 characters. We have a list of characters, and as an input we need to know Which character is A? And then let's write this down. 9 is character 4 plus A and one unknown, which will be G. Let's try. The 4 is a list of characters. No, it's just a list of characters, sorry. And if you are able to always find a 9, then you might be good. Then we have a 9. All right, let's say we go over our input. Or let's just filter first. We can actually filter down the list. We could immediately filter this. Wait a second. Maybe this is much easier. Let's sort them quickly. And by sorting, I mean sorting by number of segments they need. We have this. Oh yeah, I already copied this. Then we have the 4 segments, and we know those need 5, and those need 5. Those need 6. 9 needs 6. 8 needs 7. And we missed something. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 0 is missing, which is also 6. And one, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay. We can already filter all the ones out that are not interesting to us. Like if we are searching for the 9, let's filter everything that is not, oh, sorry. Let's immediately filter everything that is not the right length. So if we pick the 9, it needs to have 6 characters. And this means the other candidates are what did I say? The 9 are either 6 or 0. Six does not contain 4, the segments of 4. It doesn't contain C. 0 does not contain the digits of 4, so it can only be 9 that contains the same number of segments and has 6 segments in total. So maybe we do not need the A at all here. That might be much easier now. And so find all the ones that have 6, and then find the one that contains all of 4 here. And then we return it. And if we do not find it, we throw again. 9 not found. Yeah, thank you. And now we need to make this different here. So that we can reuse the things 1 characters, 4 characters, 7 characters, 8 characters, 9 characters. Now we use those here. 1, 4, 7, 8, 9. And for the 9 we need to input the 4. Yeah, let's run this and see what happens. Okay, we need to change how we do this again. First, let's execute part 2. And then let's print the numbers again. We read the input. We translate it. And then for every translation, we print the translation joined as a string with the empty string as separator. And let's print this. Yeah, awesome. We identified 9s. Awesome. Some more things to do. This means we have the 9. We have only 2 with 6 left. Maybe we can now find the next one. This is either the 6 itself or the 0. 0. So 0 has 6 segments and contains a 1. 6 has 6 segments and does not contain a 1. So we can do this. Find, sorry, what was the number we were looking for? 0. Find 0. Chars means we need this. And we are looking for the 6-digit number that is not 9, contains 1, and has 6 segments. So we need a 1 and we need a 9. And then we return those numbers that have 6 segments. That are not not 1, and that are not 9, and then we throw. Problem? Oh yeah, this is still a list, so we only take the first one. And we rewrite this. And then let's say first or null, just so that we can throw here. So we pick the one that has 6, that is 6 segments, that is not 1, and that is the first one that is not 9. Then and 1 and 9. Oh, do we sort the input now that I look at this? Well, if there are numbers we do not find, then we will know that we fucked up. We can find zeros. So we have 0. Let's mark it here too. This means only one element with 6 segments is left. That is 6, so we can easily find a 6. Find 6 chars. So 6 is the one with 6 segments that is not 0 and not 9.
Not 2, not 3, not 4, not 5, not 6.
Okay, so finding the 6 means, what is it proposing? GitHub Codepilot is proposing if it's size 6, yeah, not 9 and not 0. Yeah, that is what we want. And it's super interesting that Codepilot understood what we are doing and wrote exactly the code we would have written here. It's not like just copying whatever it saw before. So that was really nice. Let's see. The 6 characters. Input 9 and 0 chars. Yeah. Let's enter this here. And then let's run it again. Do we find some 6s? Yeah, there are 6, number 6 in here. So we have number 6. This means only the numbers with 5 segments are left. Let's see how we can find them. It's the 2, this one. It is the 3, this one. And it's a 4. Let's see. No, sorry, not a 4, 5. It's the 3, 2, 3, and 5. 2, 3, and 5. Okay, then I guess I have an idea. We need the 3 is the only one that has the segments of the 1 in it. So we take, for the 3, we take everything that has 5 segments and contains the segments of a 1. Let's write the function for 5, find. Let's see, what does the Codepilot That is not 9 and not 0. No, it just copied. It's not that smart. It just copied the implementation of the other function. So we need our input. And then we need a 1. And then we filter the input down to everything that has 5 segments. We could have, by the way, made our input smaller on every iteration and not always passing the whole input, but it's small. It's just a list of 10 things, so don't care too much about this for this exercise. And then we search the one that it contains all of 1. And then we pick the first or null, otherwise we throw. Let's see if this works. Let's run this. Okay, we have some 5s. 2 more to go and then we are done. Then let's hope it's correct. So this leaves us with a 2 and a 3. 2 and 3. Is there anything that works for both? The 3 contains a 7 while the 2 does not. Let's take this. Oh, let's mark the 5. So the 3 has 5 segments and contains a 7. Find 3 chars input, and then we are looking for wait a second, now it's smart enough, right? We pass in a 7 and we filter everything that is a 5 and contains all out of 7. Let's take another peek because there was another one, the 5 segments, 2, 3, and 5. We also need to make sure that the one we already found is not in this list. Yeah, only the 3 contains the 7. Yeah. And this is actually absolutely what we want to do. Like the IDE wants to turn this into a first or null instead of a filter and then first or null. This is fine by me. So now, yeah, that is a part where GitHub Copilot is nice. It knows we do the same thing all over again, and now it wants to exactly write this code here, and then let's see if it can do the right thing here too. Yeah, awesome. So this is really nice when it's doing like the more complex autocomplete. Okay, we have 3s. Still some numbers missing here in our list. And we have only 2 left. Let's see. We have the 3. Oh, it's only 2 actually. Yeah, so everything with 5 segments that is not a 3 or a 5. Find 2 chars. We have an input. And we look for everything that is not a 3 and not a 5. 3. No? Oh, I was hoping for Copilot to write it. 3 chars. It's a list of char. And then 5 chars, yes. We need everything here that is 5 segments, and then filter everything. It is not 3 chars and it is not 5 chars. Otherwise, we throw. Oh, and we need the first one again, first or null. And then Copilot, 3 and 5, yep. And Copilot, please. Let's see, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Let's run it. Okay, so problem is we have dots in here, and that should not be the case. Now let's take a look. I think one of the things I mentioned earlier is we haven't looked at the input. Where are we reading the input? Here. This list and this list is not sorted, so we might have this problem that I described here. Where's the example of the first one? This one here. This is the number of digits, and we might find out, okay, GF is 1, and then we look at those and see, do not find this. Instead there's an FG that is not actually here, so we definitely need to sort those. And the other ones, do we need to sort the other ones too? Oh, sorry, the value we need to sort. The other ones we might not need to sort because we sorted already. But it doesn't matter, let's just sort to be sure. Let's run it again. Okay, this finds almost all numbers. There's still a bug somewhere, because you can see there is a dot and there are 2 dots. Like, which number did we not identify and why? Because according to this we found all of them. Let's sort this here quickly. 0, 1, 2, 2, 4, 5, 6, 7, 8, 9. Okay, we have all of them. Let's make sure that they are all unique. 1 char, 4 char, 7. Oh, didn't sort those, unfortunately. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And let's make sure we want to make sure they are unique. We could turn it into a set, I guess. Let's do 2 things. First, we create the map. Turn a map. Then we make sure we have exactly 10 entries and never duplicates. Let's see, does it complain if we would do this? No, not here at least. Let's say if map keys size is not 10, and we throw. And if this is not 10 digits, then we made it unique, and we throw 2. Let's run this. Oh, digits are not unique. Okay, so we definitely made a mistake here in one of the digits. Now we need to figure out which one. So we take the values, we sort them, no, wait a second. If we do not throw here, we should not have a map size of 10, right? This is easier to print. Map size is not 10, yeah. Because now we can print line, or let's say map values for each, and then sort it, and then for each print line character, and then we see what exactly. 0, 1, 4, 5. So then 3 is not in here. So there's a duplicate between a 3 and what? How do we do this? Well, in this case we could just print it, I guess. 3 equals map values filter. No, that is wrong. That is the map of the 3 chars. If we throw in the 3 chars, we get a 5. Okay, 3 and 5. There's something wrong with 3 and 5. Let's take a look. 3. A 3 are 3 has a 5 digits. Yeah. And 3 is the one that is contains a 7, right? Contains all of 7. 3 is the one that contains all of 7, and 5 should not hit this. 3 looks okay. Let's look at 5. 5 is the one that has... Oh, here's the problem. 5 has 5 segments, yes, and it's not does not contain 1. It does not contain 1. And we wrote it contains 1. 5 has 5 segments and does not contain 1. And the other one, 2 and 3. 2 and 3 are the other ones, right? Yeah, 2 does not contain 1 either, so this is not great. We could say, let's take another peek. Where do we... 5 is the first one we picked. Maybe we should start with the 3 because it's the only one that contains 1. but 3 is already the one that only contains 7. 7 is not in those. So we can move this up and then fix our 5. For the 5, how can we identify a 5? A 5 does not contain a 1, but this is true for 3 as well. A 5 fits into a 6. May we do this? Everything that has 5 segments is a 2, a 3, and a 5, right? 2 does not match into a 6 because of the C. 3 does not. A 5 can be put into a 6. We could, yeah. 6 contains everything of the 5. Yeah, let's try this, I guess. So to find the 5, we pass in a 6. And then this is a 6. And then we say, find the first one where the 6 contains all of those elements. Let's run this again. 5 not found. Okay, this is not working. Why not? A 5 has 5 segments. 1, 2, 3, 4, 5. And the 6 needs to contain all of them. Why does this not work? Do we write it correctly? Looks correct. Do we pass in the right one? 6. Do we find 6 correctly? Find 6 just. Then that is 6 and not a 0. Everyone that has 6 segments is not 9 and not 0. 6 has 6 is not 9 and not 0. 6 looks good.
A lot of boring math later.
How can we figure this out? Let's throw in this example and find the errors. Because we have an example here, we can use this to debug it. So let's create a file. Day 8 debug. And now we debug. Let's debug, yay! Read input. Pass in the file name. And here we say day 8 debug text. And then, yeah, let's run this. Okay, interesting. We get a completely different error. Where exactly? Oh, this is now multi. It's not formatted, right? Yeah, now we need to reverse engineer it in our own code, I guess. Okay, we still do not find a 5, which is fine. Because the thing we will do is find it. We ignore the 5. We know the 5 is wrong. With that, we do not have a 2. Okay. Can live with that. We do not throw anymore here. Can get rid of it completely, actually. We do not map 2 and 5. And we need to disable this check. And let's see, 8394. So let's actually create a list again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And see which ones we are identifying correctly. 8394 is exactly what we want. So let's 8, 3, 9, and 4. We found it. There might still be an error that we find it too often, but let's see. 9781, 9781, 9, 7, 8, and 1 seems to be nice. 1197, 1197, 1197. Okay, 9361, 936 and 1. 4873, 4873, 4873. 8418, 8418. 4548, 45. That's the one we do not recognize correctly. 1. And then there is 10. Oh wow, 10625. So our 0 detection is definitely wrong. This should have found 6. And then 2 and 5 2 and 5 are missing. Those are the 2 I think we commented out. Then 8717 is correct. 4315 is correct. Oh, and we have the 0 twice. So a 0 is definitely wrong. So that was helpful, I think. 0. Find 0, which needs a 1 and a 9. A 1 and a 9. And then we say find 0. It is not a 1 and is not a 9 and has size 6. Has size 6. 0. 1, 2, 3, 4, 5, 6. And what did I forget? It's not a 1 and not a 9. It is not a 1 and is not a 9. Yeah, that. How can this be the case? And it should have been a 6. 1, 2, 3, 4, 5, 6. And this has 6 too. Did we make a mistake? Wait a second. Let's go back. Did I take the wrong number? 0 is not a 1 and not a 9? That is weird. Why did we say this? 0 is not a 9 and not a 6? Do we have a 6 at this place? We do not have. What did we do? 0 contains a 1. It needs to be a 1. It needs to contain a 1 and not be a 9, which excludes the 6. Yeah, okay. So this is definitely wrong. It contains all of 1. Let's run this again. 1, 6. Yeah, now we are talking. Let's get those 2 back in. And now let's also include our check again. Yeah, 1625. 1625. Okay. This looks great now. Let's now actually run part 2 again. Yes, okay, okay. That looks better. What do we need to do with all those numbers? Just adding them up. Okay. Then so we need to join them as a string, empty string, and then we turn it into an int, and then sum them up, and then we print this. Ah, damn it. This was actually the debug code. So make this, let's get back to the previous version, just to keep this around. And we change this part. Part 2. We get this number, and that's the right answer. Awesome. Let's have a quick recap. One mistake it looked more complicated than I thought at the beginning. I thought we need to identify each of the segments, and then from the segments we can find all the numbers again, but that is actually not needed. You can be much smarter. Instead of doing this weird thing, we can just look at the numbers or the list of characters that have the number of segments we are looking for, and then we only need to identify 3 that have 5 segments and 3 that have 6. And then by looking which kind of numbers contain which other number, we can exclude them and easily find one of them. Then we find the second one, and the third one is just the one that is not the other 2. And then it's kind of easy. We wrote this code manually for every number, but that is fine here, I think. It's just super hard to debug if you run into a problem. Luckily, there was this example that we could just run as kind of a unit test and then compare the outputs, and that made it easier to find our error. Awesome. Yeah, let me know how you solved the problem. You can find my solution on GitHub again, and yeah, see you tomorrow. Bye bye.